You need to achieve infrared images or even sequences at a certain moment. With the IRBIS software from InfraTec, this is possible. For measurements at a certain moment, it is important to store the data in real time on the computer. Especially for high-speed measurements, lossless and even timed data acquisition is required. With this simple example of a falling hot drop of water, I will show you how to measure the drops falling down always at a certain position. The Image IR thermographic camera is connected directly to a standard notebook for camera control and data storage. To detect the falling drops at the correct moment, we have an external optical sensor connected to one of the trigger inputs of the camera. The acquisition of infrared images with the IRBIS software by InfraTec can be initialized in different ways, either controlled by time schedule, or by action from external signals. For the action-controlled start of recording, means triggering of the recording, we have different types of inputs we can use. We can use a temperature of a region of interest which is controlled at the software, or we can use extended signals from different other machines connected to the PC, or from the camera where we have inputs, also digital TTL inputs, and we can use them as a single burst, multi-burst, or retrigger option. The same we can define for stopping the recording with a stop trigger, defining a stop trigger, and not to miss any images or situations just before the trigger signal comes in. We can even use a pre-trigger to pre-record a certain amount of images, which will be added to the real recording sequence initialized by the external trigger. Besides this action triggered recording, we also can define a recording list, means a time schedule, maybe for the next 5 minutes, but also for the next 5 months if you need it. And this is very detailed with even different recording conditions to be programmed. To show you the effect and the results of triggering and synchronizing objects, we have here the live image or the falling of a hot drop of water. And you can see in live image, you can barely see details because the drop is just too fast. So with a high-speed recording, we can show the complete path of the drop. And if we use the optical sensor to always start the recording at the correct time, we will get a sequence like this, where you see the drop coming into the field of view, falling on the obstacle with different behavior. And this is done for each drop coming down, initialized, or the recording initialized by the optical sensor. Another situation is if I want to freeze the drop in the air at a certain position, and I want to freeze all the drops coming down on the same position. Therefore, we are using the optical sensor to synchronize with the camera, to tell the camera, make an image when the drop is coming or when the sensor signal is coming. The result is that let me go here and let me change the scale to the correct values so that we can have a measurement here of the first drop, which is frozen. And when I replay the sequence, we can see that all the drops coming after, they are always on the same position due to the optical sensor, and they just have the different shape and can be measured easily with a profile line, like you can see here. As shown, the very flexible trigger and synchronization functions, in combination with the reliable real-time data acquisition 10 GigE and GigE, are mandatory for capturing the right moment of each application. And by the way, InfraTec's hardware and software offers much more functionalities as shown. Thank you.